For decades, the vision of personal flying vehicles has been a staple of science fiction, a futuristic dream depicted in countless books and blockbuster movies. We have imagined ourselves soaring above congested city streets, effortlessly gliding from one skyscraper to another. Today, on November 2nd, 2025, that long-held fantasy is inching closer to becoming an everyday reality. A new dimension of transportation is poised to unfold above our heads. Urban air mobility, or UAM. This concept promises to revolutionize how we navigate our sprawling metropolises. Introducing a fleet of small advanced aircraft designed to ferry people, goods. The fundamental question is no longer if this will happen, but how and when. UAM aims to use the vast underutilized low-altitude sky to alleviate chronic gridlock on the streets below. As cities grow denser and commutes lengthen, streets are reaching a breaking point. UAM isn't about more roads. It's about rising above them. A new class of vehicle will make this possible. Not today's helicopters and small planes. These are not noisy fuel-guzzling machines, but a quieter, cleaner, smarter generation built for urban challenges. At the very core of the urban air mobility revolution is the eVTOL aircraft, a machine engineered to be fundamentally different from its predecessors. What truly sets it apart is its propulsion system. Instead of a single large and deafening rotor, like a traditional helicopter, most eVTOL designs utilize distributed electric propulsion. This means multiple small electric rotors or fans distributed across the airframe. It provides critical advantages in safety and noise reduction. If one or even two motors fail, control systems instantly compensate by adjusting power to remaining rotors, continuing safely to a landing spot. Another defining feature is its electric power source, advanced high-density battery packs optimized for flight. eVTOLs produce zero direct emissions during operation, a game changer for polluted urban centers. The loud percussive chop of blades is replaced by a subtler hum from multiple small electric motors, far more suitable near residential and commercial areas without significant disturbance. Vertical takeoff and landing unlock the urban in urban air mobility, operating from incredibly small footprints, sometimes as little as a couple of parking spots. For flying taxis to become practical, they require a dedicated network of ground infrastructure. These specialized facilities are known as vertiports, miniature airports custom built for eVTOLs. They are the on-ramps and off-ramps to the aerial superhighway, built where traditional aircraft cannot. Flat roofs, parking garages, transit hubs, and standalone sites. Chief among design needs is charging, rapid, reliable stations for quick turnarounds. That requires a robust grid connection capable of huge power delivery. Vertiports are terminals too, waiting areas, security screening, and streamlined check-in. They need zones for light maintenance, pre-flight checks, and overnight storage. The key element is seamless integration. A vertiport must connect subways, buses, rideshare, and taxis. Imagine, take a train to a central hub, walk to an adjoining vertiport, then a flying taxi to a suburban office park. Development needs careful strategy, locations, zoning codes, as companies like Ferrovial and Skyports test modular, scalable designs. Orchestrating the urban sky. Imagine Tokyo, but with hundreds or even thousands of small aircraft flying at low altitudes, all at the same time. This is fundamentally different from managing airliners at 35,000 feet. Today's human-centric ATC isn't designed for such volume in complex urban environments. We need urban traffic management, UTM, a highly automated, data-driven system designed to orchestrate eVTOLs and other low-flying aircraft, managing paths, separation, and dynamic deconfliction. Each aircraft continuously shares position, altitude, speed, and intent with the network. The network, in turn, provides automated instructions for safe, efficient corridors, like GPS for the ski. UTM relies on detailed 3D city maps, including static and temporary obstacles. It integrates real-time weather, rerouting around localized winds and storms. AI predicts conflicts before they happen and optimizes network safety and efficiency. Building robust UTM requires collaboration with the FAA, EASA, and NASA, aiming for standards deployable globally so London speaks the same safety language as Singapore. The successful implementation of urban air mobility holds transformative benefits for cities and their inhabitants. Shifting trips to the air can free capacity on overburdened roads, shortening travel times and reducing daily stress. Less congestion boosts economic productivity and a more fluid transport network. eVTOLs can deliver paramedics, transport organs or blood, and evacuate people from danger. In disasters, when roads are impassable, they provide a vital lifeline for aid and search and rescue. Faster response can save lives and strengthen city resilience. A new industry fuels jobs: aerospace engineers, technicians, software developers, and urban planners. Manufacturing, construction, and hospitality expand with vertiports and fleets. Replacing car trips with electric flights cuts carbon and local pollutants, while quieter operations make cities healthier and more pleasant places to live, work, and breathe. Despite rapid progress, significant challenges must be addressed with caution and diligence. Regulators must craft new rules to certify aircraft, train and license pilots, and approve operational frameworks for UM. Safety demands thousands of test hours, redundancy, battery failure simulations, and adverse weather validation. Highly automated UTM systems must be protected from hacking and systemic failures. Communities will scrutinize noise, visual clutter, privacy, and hours. Trust must be earned through impeccable safety and good neighbor operations. Early deployments should build confidence and demonstrate clear benefits. Early costs are high: aircraft, vertiports, and power, making first rides premium until scale and maturation reduce fares. Charging fleets will strain urban grids, requiring upgrades. Solving economics and infrastructure is as critical as the tech. We stand at a fascinating inflection point. The dream of the flying car is being meticulously engineered in workshops and on test fields worldwide. The path from concept to common transport is complex. Certification, digital airspace, vertiports, and public trust. Yet progress has been extraordinary. Battery technology, electric propulsion, autonomous systems, and prototypes repeatedly taking to the skies as investment and regulators align. The rollout will be incremental. Limited routes at first, perhaps airport to downtown with a pilot in the cockpit. Early services will refine systems and build confidence. As records grow and costs fall, the network expands into daily options. This is not just about a machine. It is about reimagining cities, new connections, fewer frustrations, cleaner, quieter, more efficient urban environments. If we navigate with wisdom and foresight, The sky above our cities will become not a limit, but a new frontier of human mobility. So, yeah, it's getting pretty serious.